Hey guys, welcome back to our channel Get Place One. In this video, we are going to solve a problem on the arrays playlist. It is the 11th video in the series of arrays playlist. So the problem that we are going to solve today is move zeros to an end. This is also a Leetcode problem number 283 with the title Move Zeros. So without any further delay, let's get started with the problem. According to the problem statement, in the given array, we are supposed to shift all the zero elements to the end of the array while maintaining the non-zero elements order. So here in this array example, the non-zero elements are 9, 2, 3 and 6. So we are supposed to maintain the order 9, 2, 3, 6 and we are supposed to move all the remaining zeros to the end. Similarly, look at this example. Here the non-zero elements are 8 and 9. The order 8 and 9 should be the same while moving the zero elements to the end. Similarly, in this array, we have one zero element. We'll shift that 0 to the end while maintaining the order of non-zero element, that is 1, 5, 2, 6, 3. 1, 5, 2, 6, 3. So let's see how to solve this problem. The idea is to traverse the array from the starting to the ending, and whenever we found a zero element, we are supposed to shift it to the end right. Whenever we found the zero element, we swap it with the first non-zero element found on the right side of that element. So to the right of the zero, we will traverse again and swap with the non-zero element. So let's see how it works. According to our idea, when we are traversing in the iterations, if we found a non-zero element, we just move ahead. If we found a zero element, we swap it with the rightmost non-zero element. So as of now, at the starting, I is equals to 0, which is a non-zero element. Therefore, we move ahead. Now I is equals to 1. The value is 2, which is also a non-zero element. We move ahead. Now at I is equals to 2, we found a zero element. So whenever we found a zero element, we should swap it with the rightmost non-zero element. To do that, I am taking one more pointer, that is j. J starts from next element of I. So right now I is equals to 2. So j is equals to I plus 1, that is j is equals to 3. So from 3 to end of the array, we will check. 3 is a 0th element, 4 is a 0th element, and then we will stop at index 5, that is non-zero element. Now we will swap the zero element with the non-zero element. So 3 comes here and 0 goes there. Now after changing, the array looks like this. Now again continuing with the iteration, at I is equals to 3, again we found a 0th element. When we found a 0th element, we are supposed to swap it with the rightmost non-zero element. So I is equals to 3, so j is equals to 4, j is equals to 4 is 0, j is equals to 5 is equals to 0, j is equals to 6 is not equal to 0, non-zero element, so we'll stop at 6. So we will swap non-zero element with the 0th element here, and the array looks like this. Again we will continue the iteration from I is equals to 4, it's a 0 element. We will check for the non-zero element. So j starts from 5. J is equals to 5 is equals to 0, j is equals to 6 is equals to 0, and we are left with no more elements, which indicates that there are no more non-zero elements to the right side, which states that we have completely solved this problem. All the non-zero elements are to the left side and zero elements are to the right side. This is how we solve this problem. Now let's see the code and its complexity. Here according to the code, first we are taking a variable n, which is the length of the array, and we are traversing the array from the first index, that is 0th index, to end of the array, that is n. Now while traversing the array from starting to ending, if we found any 0th element, if array of I is equals to 0, then we will take one more pointer, one more loop, j, it starts from I plus 1. So we found I is equals to 0, we are supposed to search in the right side to that element. So j is equals to I plus 1 and j goes till end of the array. And while traversing j, if j founds any non-zero element, we swap this non-zero element with the 0th element at I. So this is how we swap these 3 lines. We have discussed in the previous videos also. To swap, we will take a temporary variable. We will store the I value in the temporary variable and we will update the jth value in the ith value. Again, we will update j value with the temporary value. So this is how we swap. So I hope you understood how we will solve this problem in code. Now let's talk about time complexities. The time complexity is O of n square, because we are using a nested loop here. We are traversing the array twice, right? First time when we are searching from starting to ending, and the second time array not only second time, it may have to run multiple times whenever there is a 0, whenever encounter is 0, and this is a nested loop. Therefore, the time complexity is O of n square. The space complexity is constant, that is O of 1, because we are not using any extra additional spaces. Here we can see that O of n square is quite large. So we can try an efficient approach by reducing the time complexity. So let's talk about the efficient approach. So the idea here is to keep track of number of non-zero elements encountered. So 9, 2, 3, 6, there are total 4 non-zero elements. And whenever we encounter a 0 element, we replace it with the next non-zero element found, but with the position indicated by the count variable. Earlier we need 2 pointers, one for the position and one for the non-zero element, so that we can swap. Here, without using 2 pointers, we are keeping a variable with the count of non-zero elements, so that with that variable value we can change the positions. So this is the idea. If you do not understand the idea, don't worry, we will look at the iterations and we will understand. So getting started with the iterations, but before that, according to our approach, whenever we found a non-zero element, we move the element with the index of count and then we'll increment the count. So at starting, initially the count value is 0. Okay, and I is equals to at 0 right now at the first element. Now at the first element we have encountered a non-zero element. So we are supposed to move it with the index of count. So initially count is equals to 0, index is equals to 0. When we move, it stays there only. Once the move is completed, we will increment the count, that is equals to from 0 plus 1, count is equals to 1. Now moving ahead, we have index is equals to 1. It is also non-zero element. We will move the index 1 with the count, earlier count. It is also 1 only. So the 2 does not go anywhere after move. Then we will increment count is equals to 2. Moving ahead, we have index 2 is equals to 0, index 3 is equals to 0, index 4 is equals to 0. So whenever we found a 0th element, we will just ignore it. And then at index 5, we have value 3, which is a non-zero element. So what is the first step? The first step is to move the element with the index of count. So we will move the index 5 with the count 2. So we will move the 5 with the 0 element, which is at index 2, the count value. So after move, it becomes like this, right? So 3 comes at index 2. After moving the 3 to here, what we'll do, we'll increment the value of count, that is equals to 3. Now moving ahead, at index I is equals to 6, it is also a non-zero element. So we move it to the count value, that is equals to 3. So from 6, it will move to index 3. After moving, it becomes like this. So now I is equals to 0 to 6, all the elements we have, from I is equals to 0 to I is equals to 6, we have traversed the entire array only once. And now you can see that all the elements to the left side are non-zero elements and all the elements to the right side are 0 elements. Now moving ahead, and let's understand the code. Okay. Also we will increment the count value from 3 to 6 after moving the element. So let's check the code. In the code, you can see we are creating a variable count is equals to 0. We are initializing it with 0. We have one more variable, that is n, which stays the length of the array. So we are traversing only one loop. You can see one loop. There is other loop also for other purpose, but it is not a nested loop. So in this loop, in the for loop, we will traverse the array from I is equals to 0 to I is equals to n, I less than n, which means from starting to end of the array. So in case we found a non-zero element, first we will move the non-zero element, that is array of I, this value array of I, to the place in the count variable. After moving, then we will plus. After moving, we will increment the count value. Okay. So this is how we traverse. So by this step, all the non-zero elements will be coming to the left side, right? So in this loop itself. But we are writing this while loop to fill all the remaining values from count to end of the array with zeros. So I hope you understood the code. This is how we solve the problem in the efficient approach. Now let's see the complexity. The time complexity is O of n. Here you can see the time complexity is reduced. Earlier it is O of n square. Here you can see we are traversing the array only once. There is no nested loop, right? So we have a for loop that is O of n. We have another loop that is while loop that is also O of n. So O of n plus O of n, which gives O of 2n. And when we ignore the constants, ignore the numerical values, then it becomes O of n. So the time complexity is O of n, and the space complexities remains constant, that is equals to O of 1, because we are not using any extra additional space. So that's it about this video. I hope you like this video. I hope you understood it. If you have any doubts, make sure you comment below. Please like, share and subscribe to our channel. Get Play soon. Thank you so much for watching till the end. Bye bye.